Okay, so here's our first lesson in statistics. Section 1.1 is going to have a bunch of definitions because we need to learn the language of statistics in order to figure out what they want us to do. Okay, first one is data. Data is any observation that has been collected. It can be numbers or it can be categories. So if there was a classroom of students and I got everybody's height, then all those observations would be data. So that would be a number. If we looked at eye color, I got everybody's eye color, then every color that I have collected, that's going to be data. And that's going to be a type of category, because it would be color. Now, if I looked at one person's height or one person's eye color, so that'd be one single data value, that would be a datum. Okay, here's the big idea with statistics. So we've got a population that we want to know something about. Usually that population is way too big for us to look at. It's too big, it'll take too much time or too much money. So what we're going to do is we're going to narrow it down to a sample. So we're going to pick fewer objects from that population. In order to do that, in order to go from a population to a sample, we're going to use a random sampling technique, which is going to be looked at in section 1.2. So once we have our sample and we look at the height of everybody in our sample, then what we're going to do, so say we find the average height in our sample is 5'5", okay? What we're going to do is all the information we found from the sample, we're going to apply it back to the population. So we're going to say, on average, everybody in this population is about 5'5". So with us applying what we know from our sample to the population, that is called inference. Use what you know about the sample and apply it to the population. That's the big thing about statistics. Okay? Now, a population is a complete set of elements being studied. Usually with some kind of characteristic in mind. So say we looked at every student at Delta. That would be our population. And we're going to look at their height. That's the characteristic that we have in mind. We can't look at every single person at Delta. Okay? So we are going to have a subset from that population, everybody who goes to Delta, and say we pick 50 random students. Okay, so that would be a sample. So in my picture, population is the world here. Way too many people to look at the world if we want to find the average weight of people in the world. So we're just going to narrow it down to just a few people, and that's going to be our sample. Okay. Big thing about a sample is you want it to be representative of the population. So you want the same characteristics in your population and in your sample. If you miss out on one characteristic in your sample, but that characteristic is in your population, well then your sample is not going to represent your population. And remember, the sample is the thing that we are looking at, the only thing that we're looking at, and we're applying what we know from our sample back to our population. So I got two characteristics here, okay? If I had just asked these guys over here, so this is the dark characteristic over here. If I just asked these three guys what they thought about world domination, okay, or space domination here, do you think it would be completely different from Yoda's perspective on that? Well, definitely, okay. But if I just ask one of these two and didn't include the other, well then my sample is not going to look like my true population. Okay. And by the way, make sure you don't have samples that are really small. Like if you have 3 people in them, that's way too small. You're really going to miss out on a bunch of characteristics. Okay, we have 2 areas of statistics, inferential and descriptive. So inferential methods that take a result from a random sample and extend it to the population, inferential statistics, and then measures the reliability of that result. Measuring the reliability is in chapter 9, 8 or 9. Descriptive statistics is basically finding the average, finding the standard deviation, which we'll talk about way later, finding the proportion of people who have brown eyes. Okay, proportion is just a fancy word for fraction, by the way. Okay, or making a table or making a graph. Okay, you're describing your data by a number, by a graph, by a table. Okay, now we can break down descriptive statistics depending on where it came from. If it came from your population, then any number that you got from your population, that is called a parameter. If your number came from a sample, then it's called a statistic without an S, because remember, statistic with an S, that is a very broad term. It's everything that a statistic is about. So population, parameter, P and P. Sample, statistic, S and S. That's how I remember it. Okay, so let's see which one is a statistic or a parameter. First one. In an AAA Foundation for Traffic Safety poll, 21% of the respondents said they recently texted while driving. Okay, so you sent out this poll. Some people responded. Those are the respondents. Out of those respondents, 21% of them recently texted. Okay, so since we didn't ask everybody, we just had a few respondents. It wasn't everybody. This is coming from a sample, so therefore it's got to be a statistic. So I'm just going to write stat. Okay, the average age of the employees in a certain company is 35 years. Okay, so they looked at this company and they found the average age to be 35 years. Now they didn't say we looked at just a few. They said we looked at the employees at this company. So they're looking at all the employees at this company. So since the 35 came from the population, this got to be a parameter. I'm just going to abbreviate para. Okay. Of the students enrolled in a certain college, 80% are full-time. That's the same thing. It didn't say we just took a few. It just said of the students that go to a certain college. So of all the students who go to a certain college. So that 80% is coming from a population or a parameter. Okay. In a survey of 500 high school students, 60% of them said they intended to go to college. Okay. So anytime you see a poll or a survey, that's going to be a sample because you're not including everybody, because everybody has the option of saying, no, I don't want to take that survey or poll. So this is going to be a statistic. Okay, the IQ score, or the mean IQ score for subjects taking the WAI IQ test is 100. Okay, so the people who took this test, the mean is 100. All the people who took this test, the mean is 100. So since it came from a population, it is a parameter. In a random sample, I can stop right there. It's got the word right there. Sample. This has got to be a statistic. The average atomic weight of all elements. I can stop right there. It's talking about every single element. So this is a parameter. Interviews of 100 adults 18 years of age or older conducted nationwide found that 44% could state the minimum age required for the office of the U.S. President. Okay, so it's conducted nationwide. So are there only 100 adults 18 years of age or older nationwide? Of course not. There's a whole bunch of them, right? Okay, so if we're only looking at 100, but we know there's a whole bunch more, then that means that the 100 is actually a sample, which means this 44% is really a statistic describing that sample of 100 adults. Okay, just want to make clear, there is a distinct difference between statistics with an S and statistic without an S. Statistic is a broad term talking about collecting, analyzing, summarizing, interpreting, and drawing conclusions from the data that you collected. Whereas a statistic without an S is what we just did. It's a number describing a sample. Okay, a census, it's a collection from every member of a population. So if the population that you're looking at is not too big and you are able to get a data or data from every single, say, person in that population. Once you do that, that's called a census. A voluntary response sample. This is really big with surveys or polls like you see on Facebook, or surveys that you see on YouTube videos before you watch the video. Now you decide if you want to participate in that survey or poll, or if you don't. So you say, yeah, I'll volunteer myself to respond to this, or no, I will not. Okay? Probability, we'll get into more of that in chapter 4, but right now just know the definition is a mathematical tool to study what? To study randomness. And then a self-interest survey. A survey in which a sponsor can enjoy monetary, money, or other gains from the results, if the results go in a certain direction. Okay? So if someone is conducting a survey, say it's a doctor. Okay? It's a doctor who is looking at this drug to see if it works or not. If the drug does work, then he can sell the drug and get money from the drug, right? So if he's conducting an experiment on it, then he might want to, or she might want to, fudge the numbers just a little bit to go a certain direction. Or you could say a restaurant owner. Say they hand out surveys to their customers of, are burgers good? If they can get the customers to say, yeah, this is great, or maybe they pick out the ones that say, yeah, this is great, and they just look at that and they post that on their billboards, which I'm sure companies do anyway. If there's any monetary gains or any kind of gains that is going to result in some kind of benefit towards the person who's conducting the survey, you need to be wary of those, because the person who's given the survey would be tempted to make the results go in a certain direction. Okay, now anytime you've got a voluntary response, you're going to have non-response in it. And it occurs when someone either refuses to respond to a survey question or is unavailable. Say they missed a phone call. Okay, so there's two different types of characteristics here. There's people who will say, yes, I will take that survey and go through it. And then there's other people who are maybe more private or just too busy, and they'll say, no, I can't do that right now. So that's two different types of characteristics. People say yes, people who say no. Two different types of characteristics. So all the people who said no to that survey, you're missing their type of characteristic within your survey. So the sample that you get from that survey is not going to represent your population. And if it doesn't represent your population, there's no point in looking at that data that you got, because you've already missed out on a characteristic from the people who didn't respond. Okay, now a variable is a characteristic for each person or thing in a population. It can be numerical or can be categorical, and we label it as X and Y, basically just a capital letter. Now, a numerical variable could be, well, it's going to tell you how much or how many of something there is. It's also called quantitative variables, which you'll see that a lot. And then category variables is just a person or thing in a category, and it's qualitative variables. Okay, so how I break it down is the root word of quantitative is quantity, so number. The root word of qualitative, quality, a quality of something or a category of something. Now we can let X be the number of points earned by a math student at the end of the semester. So since X is representing points, that is a numerical variable. If we let Y be a person's party affiliation, Republican, Democrat, or Independent, because Y is one of those three categories, it's a categorical variable.